programming, those properties and behaviors are also very important. Now, when we talk about the properties, we are talking of those things that are unique, that we can uniquely use to identify those objects. Like when you take, for example, you have a desk in front of you, you have a table, a chair, or even the laptop or phone you are using. These things are objects that we can model in our programming. And then if you look at, for example, the laptop you're holding, the laptop have a color. And then if you look at it is a table, it has some legs, it has a top, it has also a color and different things. And if you take, for example, humans in our environment, know that human being also, it can be uniquely identified, and both in terms of their behavior or the actions or the ability that they have, or in terms of their unique features. And you see, human, we can also say that human, we have color, we also even have gender, we have different properties that distinguish one human from the other. That first, JavaScript uses what is called prototyping in OOP feature. It's not like any other OOP based class like Java, but it uses this prototyping method to achieve its object-oriented programming. And then when we are creating functions, those functions we are creating are actually objects. And also in OOP, when you create a class, you instantiate that class to create an object that has the properties you define in that class. So JavaScript really is a class-based, it's not a class-based object-oriented programming, but inheritance prototype-based programming. But the most popular of this type of programming, object-oriented programming, is class-based. So what happened then in 2015, the JavaScript team now introduced the OP, the class-based feature in JavaScript. And that made it easy for guys who were familiar with the class-based OP feature to like JavaScript more. Most of us people were coming from backgrounds like Java, they were able then, it would then be very easy for you to do something like using the class base to write your JavaScript code. Okay. Yeah, so let's get down to our code again. Okay. Now, you can remember, let me make the JavaScript code here first. It's our script. Let's see here. And then we have JS and OOP. Okay. So let's go to our OOP class now, OOP file. You remember that was a time we were creating things like let object, let's say we have object product, something like this, we created, and then we put name like this, and then we say this is iPhone 12, let's say that's the name of our product, and then we could say color, and then we say silver. And this is an object, and if you construct this object, if you can, you can get the properties of this object the way I showed you earlier, just the object name and then a property name. But let's construct the entire object now and say product. Let's look at our console. If you look at your console now, you open this object, the product which we log. These are the two properties we've added, name and color. But then you are seeing something else, the third part of it, which is something you can still open, and it's saying that the type of this data is an object. So if you open here, you see what you're seeing here is prototype. That's why I say JavaScript is a prototype-based object-oriented programming. If you open this prototype, you will see different features and methods. You see constructor, you see hash property, has own property is prototype of, and different other ones, value to string are there. You even see this underscore underscore to underscore underscore different properties and method that are in that same object. But all these things we are not defined by us. That is to say, every object inherits, or once you create an object in JavaScript, is going to have these extra properties. But these properties are, you can use them to get one or two things done. But once you define the properties you define, like in our case, the name and then color, when you are manipulating these, they are default things that you can easily manipulate. If you put the property product dot, you see that it's basically these two that we are seeing, but you can actually access all these other properties here using the prototype method you are seeing there. If we say now, we have something called a has own property. If you say has own property, and then we put the name of the property, we're expecting that this product have a price. And if we console log here now, it's saying false. It means that inside our product, we didn't define anything like price. But if you change this to name, okay, and then you see that it has true. But how does this has own property comes to be? It's possible because every object is having all the properties and that are included in that prototype you were seeing before. So if we clean all this now and log this again, you check again inside the prototype, and you'll be able to see hash own property. You'll be able to see this hash own property here. That is what we're able to, although it's not defined in our object, but you can access it. And you can also call the constructor. You see there you have what is called a constructor. If you log this down, what you are going to see, I think the constructor is not a function, it's just a property. See, undefined. If all those things inside the property, you can get them. The constructor is a function. If you open that, you can also see different of them. You see the assign method and the create. Now let's proceed with things that you can do with this object-oriented programming in JavaScript. Okay, so we have seen that when you log the object, you see other property from the prototype that belongs to the prototype property in an object, and then when you call any of those methods, you will see them doing what they are supposed to do. So you don't need to put any of those property in the object; they are already there by default. Okay. So if you also call object.create, that is this object, and then you call the create method, and then you put your product, you are still calling those properties of the prototype, which you are using, which will be used to create the object. So if we log this, let's pick this now. Let's pick this. But once you create an object like this, the object has already been created, but you can still be using those methods inside the property. Now, when you do this, you have created an object, and the object you've created is having those properties. You should now look at inside our prototype. The default object when you log the product is empty, but when you now move inside the prototype, you now see those properties defined in the product. But if you don't do it like, if you don't call this create method on it, and you just log the object, the prototype will not have these properties created. It will belong in the top level of the product object you just created. But if you call object or create like this and you put the object name which you've created, it's going to pick all those properties and push them to the prototype level in your object. Okay, now we look at when we we are using the function, I think it was when we created a product using a function, we used the new keyword. A new keyword is very helpful when we are dealing with objects in object-oriented programming. It's what is used to create the object from your object definition class. So once you created your object class, you can then, or if it's a function, you see, you can still use the new keyword to instantiate it and create a value or a variable that has the properties of that object definition or the class or the function which you created. And all those properties you specify will be assigned to the variable you are creating with it. And we also see that an object can be created with a function, can be created with a class. Now, I told you earlier in 2015, when JavaScript added the class keyword, it became very easier to create objects or to do object-oriented programming using classes. And in that case, what we can do after that time, we can then use the class keyword, which is this, to create classes, which we can use, which can be used to create objects of the class type. So in this case, let's say we want to create a product. If we want to use the function base, what we could do is to say function and say this is, let's call it capital product. And then this product is expecting name and color. You can say it's also expecting price. And you remember what we were saying, you said this dot name is what we did earlier in our previous class is the name you are passing. This dot color is equal to the color you are passing. Then we can also say this dot price is equal to the price the person is passing. Now, if we want to create a product here, we can then come here and say const product one is equals new product. Now we are using the function that is expecting us to put the properties now, the name, color, and price. So we can then say here iPhone 14 Pro Max, okay, and then we come again, put our comma here, and then we say the color, and say the color is say the color is light gray. Just call it gray. And then we come and put the price. So the price is $1,200. Okay. Now we have, sorry, I'm doing this now as if we are creating an object. What we can just put is the values. That's a TypeScript project. So once we do this, if we come now and then log our product one, this is a revision. We've done this before. If you log product one, and then you put product one here. Let's see our code now, our console. You see, this is our product one. It's telling you that this product one we are logging is of type product. You see, the first one, when we log this product here, is it will not give you the type of this variable, okay, but you will the values in that object. Yeah, if you open this, there is nothing that tells you the type of this variable, because this one now we are using the new keyword. This is a function we are using to create the object. We are making use of everything in the prototype there. We are creating an object afresh now using the new keyword from our function constructor here. And then we can see the type of function, the type of the product, and the type is usually the function name. Now we see that we have the product have the three properties we gave it, the name, color, and price. Now, when we are doing the object oriented using class, how we can define this is to say class product, and then we put open and close brackets. See, this is now a different way. You don't need to use the function keyword again. You need to replace the function keyword now with the class keyword. And then you don't need the brackets to create a class. This bracket here in the function to get your function constructor is not necessary. You can then create your constructor inside here, inside the class. So this is now where you can have the constructor, and here you can then have the name, the color, and then the price. This is here where you can then specify this. And all the same thing we did in the function type, like calling this dot name is equals name. This is now inside the constructor is where you can do this. You are now creating, you know what I told you earlier, when you say this dot inside a function or a class like this, you are referring to the object, the parent object. So we're referring to this particular product. We say now this product has a property called name. We're creating the property here, and then we are assigning the value to what the person is passing in our constructor. And then we can say it also for price, and let's say this the price is equals price. But now, when you are creating this product, you if you want this product to have the values you pass from the constructor, it means the constructor must be called with the properties you are expecting here. If any one of them you didn't add here, you are calling the product constructor, it will not be, the property will be not undefined, it will not be created in the product. So if we come here now and okay, now let's comment this other one. I think it will lead to conflict since they both have the same name, but let's see it. Let's see, it's always good to try something. Let's say now product 2 is equals new products. Now, which of these products are we calling now? Let's see which the one is calling. Let's just change the position of this. Okay, now if you put up console here, you see what is still calling is the up one, which is that of the function. Because if you look here, the first expected property is name before color. So we have, let's comment this other one so that we can make use of, let's copy this one, then we'll comment it here and then comment this function. So here we then need to put every of this property here. So let's clean up all these ones. Okay, we've done what we needed to do here now, and we call this product 2, so change this to product 2. So what we have done now, we have still been able to create our product class, which we still be able to use to create our product object. And with this class or the function that's at the other time, you can create multiple products that will have different name, have different price, have different color. It doesn't matter. Once you call the product, you'll be able to pass your new values. So if we come here and you see, we still see in the product 1, which is what we log here, you are still seeing that the type is still product. Whether you define it with that function or you use a class base, you still have the type here as product. And all the properties you pass, the name is iPhone 14 Pro Max, and the price is $1,200. And if you open it, we have the color. You're still able to see the color here. We have color here. Okay, I'm looking for.
Hello, sir.
Yeah,
Hello, sir.
yeah, I'm with you.
We are not able to see the color because when you are saying this is price, it did not
Oh
add
yeah, yeah. Thank you,
price.
thank you, thank you. I didn't notice that. Thank you. This is okay. But I couldn't imagine. Okay, now we see the color is here now. So that omission resulted to the color not being part of the properties. And then the other second value here overwrote that of the previous value for the price, which was still cool. So now we see what we are having now. We have been able to create an object of a property or of type property using our new class. Then there is something also very interesting about object-oriented programming with class like this. Let's say this is a product. Every product have this kind of these three property: name, color, and price. Now, what if we want to create different types of products that belong to different category? We want to, and let's just come here and say create a new class. Say class. Let's say electronics. Electronics is now part of our product. Let's say product type. Let's just electronic, and then we can then use what is called the extends keyword to extend our product. Now, if we look at this here, this extend keyword is telling us now that our electronic is a product. It's going to extend the product class. And what this means is all the properties you define in the product will also be found in electronic. Although electronic is not the same as product in terms of the class name, they are different classes, but electronic is extending the class or called product. So if you come here, you can see if you say this dot name, let's just create a constructor first. Let's say construct, and then we put now a brand. Let's say Pro Electronics has brand. And then what else do we have to put for electronics? I think this is okay. We're just demonstrating something. If you come here now and say this dot, you see that we are finding our color. You see, you can now access the color, the name, and the price properties, which are defined in product. These things are not defined in electronics, but because we extended the products class, we can be able to access them and override them. Now, in this case, we are saying the color is going to be color. So what we can do now, we can have a different, expect the different colors to be here. And mostly when we do this, then let's first finish what we are trying. We can say color here. And then we can also say our name and then our price. So we can come here and say color is equals color, and that this dot name is equals name. This dot brand is equals brand. This dot price is equals price. Okay, so if we want to, let's pick this now and just copy this. Yeah, we call this now electronic, and then we call the product, let's say this is TV, smart TV, smart TV. Okay, and then they say the color is black, the price is still this, no problem. Now we can then add the new property, which is the brand. The brand is in the third position, so we can say here now is XG, and say and the brand is XG. So if we log electronic now, we do yes, and we console log. Yeah, let's come here now. You see our electronic is still of type product. You see how amazing this is? It's extending the product class. That means electronic is also a product, but it's going to have more properties which we can add to it. If you just created a first product, we created an iPhone. An iPhone is a product, but it's not. Let's assume now an iPhone is not an electronic, and so it will have a brand. We don't give it the property name of brand, but now in our electronic product, we have a name, a property that is called brand. Now, if you look at this here, you will be able to see the brand. Now, where we see our brand here, name, price. We have anything for brand. This brand equals brand. Brand is even the first one. Okay, yeah, we are having brand here. We have, I missed their position, which is not bad. We still have our property in the same, all of them are visible, but just that missing of that makes us to be looking for, okay. So if we come here, we can see in our name is still, what do we have? The name is what is, okay, color is smart TV. I'm still missing this property. The second one is color. Let's remove this here. Color is the second, and then I just get crying. Okay, I'm just trying to locate where our We have name Smart TV, black, and then where is XG brand? Oh, sorry, I'm the one causing the whole havoc. We didn't call electronic, we are calling product. Oh my God, this is really serious. So I can return this back to the usual, the constructor we created. We have brand, color, and name. So let's move this to the third position. Okay, so let's go. So this is going to be in order now. The name, where do I have error? Oh, sorry, we are missing in the constructor. When we extend super is compulsory, you call super. Yeah. So our code is in order now. When you look at the electronic, they type electronic, and then we have the brand LG, the color black, name Smart TV, and price 1,200. Any question at this point before we move on?
No, sir.
Is it clear or it's like it's confusing? You want to resolve the
No,
question?
for what I understand, this extension is when you're trying to add more products to a given, when you're trying to add more values to something, instead of starting the code afresh, you just
Yes,
use extend.
exactly. When you already have a class that has more of the properties you are expecting for this particular feature you are adding, then instead of creating the class afresh, because the class is actually a blueprint of an object. It just tells you the properties and the functions that are in the object or the method. So instead of creating it afresh, you can just extend the existing one. If we have in the product, if we have in this product any method, like let's say in the product we have something like play as a function. So let's say function play. Let's remove this unnecessary. And then we just want to console log product that is playing. I think this function is not necessary. Yeah, in a class, you just call the name of the function and remove the function because the method will be captured like that. So when you create the function outside, like with the function, it's seen as a function, but when you create it inside a class, it's usually referred to as a method. So in our electronics also, this particular play, so let's say you don't play a phone, let's say, and let's say boot, boot device. Okay. Now we can override this method, write our own method for electronics. So we can come and say play. You see the play that was in the other one is there, but we are now rewriting the play. If we come here now, we can then say another log message and said TV electro electronics electronic is playing a movie. If we log in this product now, we say sorry, in electronic we say electronic dot play, and we log here. What you are going to see, what am I seeing? Console.log. Oh, sorry. Yeah, we've seen that electronic is playing on top. I was looking at the wrong place. So you see, this is the message we put here that is going to show. But if we remove this method in this particular electronic and we log again, what you are going to see is the first method, boot device. Now this one is coming from the product class, the parent class that we extended, and what we have there for play is boot device. But once you overwrite it in this your subclass is everything that the method we do is going to change. Everything that it will do will be changed to what you wrote inside the method in your subclass. So when you extend a class, both the properties and the method in that class are all going to be inherited. It's usually used for inheritance. So in object-oriented programming, inheritance is the way you make the properties and the actions or method that exist in a parent class to become available in a subclass, usually referred to the child class. So in this case, our electronic is the child of parent. Okay, let's keep pushing little by little, we'll get somewhere. So one thing I needed to get very important here, let's also test what we were talking about in the object, looking at those prototypes related stuff. So now you see, we just load the electronic so that we can see the things that are in electronic. We open here, yeah, we look at, when we open the electronic here, inside the electronic, remember, just look very closely. You see that the electronic, inside the prototype is saying that this is still a product. But at the top level here, we are seeing electronic. Now, let's go back again. You see you have the proto, and that's like the constructor inside the prototype. And inside there, you have the method play, which is the method we define in the product. Even if you remove this method in this electronic, it will still be there. Okay, if we remove this method and call back our class, come back again to our proto, sorry, the method is not there. I think, yeah, it's coming from the electronic itself and not from the parent class. It's coming from the electronic directly, not from the product. Okay, I was mistaking it to be coming from a product. Now let's look again. The same thing, though we use the class to create this object, but you can see under the hood, JavaScript is still doing that prototype-based object-oriented programming, because it will take your class definition and still use the prototype type which it was doing earlier before 2015 to create your object. And that is why JavaScript is still regarded as a prototype-based object-oriented programming, despite their introduction of class, which is popular among the object-oriented programming languages, is still a prototype-based language in the background. Those object-oriented features you see on the class features you see is just something like a quote. You are using like icing on a cake. You just, after you finish the cake, you wrap the icing there, or you just sugarcoat it so that it will become more pleasing and more appealing for people to look at and more attractive. But in the background, it's still doing what it used to do before using the prototype. So now, in conclusion, in these features of class-based in JavaScript, class-based object-oriented programming, JavaScript is just leveraging on the prototype nature to make new developers welcome to its ecosystem. And that is why they introduced those classes on top of the prototype features it uses to organize its related data in the background. So if you are used to using the prototype method, it's fine. You will still be able to get your job done. And the prototype method, like what all these method function we are creating here, we can create them in this object. If we come here and we say product dot prototype dot, we say say, let's say this is a function, then we can create the function like this, and let's just create this as an arrow function, and then we say log console.log selling product. Is the same thing as creating a function inside this particular function, or creating something, a method like play inside the product class. We are now using this, in this case, we are using the prototype nature of JavaScript to be able to still work around it to get some things done. So whichever way you use to get your code done, but it is always more clean and appealing to use the object-oriented approach in using your code, or at most using the function to get your code done, because it's usually clean and looks more easy to work around and maintain. In fact, most modern work you see on JavaScript works around functions and class base. From the ES5, I think so, yeah, 2015, you see most of these things now. You see class-based JavaScript work is in the increase. You see it everywhere, and especially with the introduction of TypeScript, most people are adopting TypeScript, uses class-based programming, object-oriented programming, adding, and then those code being compiled down to JavaScript. And but at the top level, the code you are writing looks more clean and easy for you to understand. Okay, before we proceed, I don't know if you have any question. Any question? And I was saying this tuple, you know, the first time I omitted this, it resulted to a problem. Once you extend, you look at in our constructor for the product didn't extend anything. Okay, and then we didn't need to call super. But this case, we are extending a product, so we need to call super. This super we are calling means that we are also getting the constructor of the product which we are extending in the electronic. So if you don't call the super, it will JavaScript will complain. Say, hey, when you are extending, I'm expecting you to call super so that I can be able to do what I need to do. Are we good to go? Hello, Chinedu, are you getting what we are doing?
Yes, sir.
Okay, and Destiny.
Yes, sir. I'm with you, sir.
Okay. So what do you think from the way we have been writing code and then creating a class like this? What do you think about the organization of the code? If we you remember the login we did before, if we are using object-oriented programming, what we could have done, we have to create a class called login. You know, but then we are writing all the functions in the login file. Then if we created the login like this, we can then say a constructor, call it a constructor, and then maybe we are expecting the email, and then we are expecting the password. Then we can say this dot email equals email, this dot password equals password. Then you remember we had a method called validate email, validate email. So what we could have done, what we have to do that we create the method like this, then we can write all the code we needed to write there. We also have a method called validate password. Then we could also write all we wrote in the other method here. Then we had another method called submit. So here we could also see all the three methods we wrote in that file with different functions. We organize all of them under the class login, so that once you instantiate the class login anywhere, let's say in where you need to use it, you can then say login.validate email, login.validate password, login.submit, and your code is pretty well organized in a class. But also when you write them in a functional way, each of those functions are not independent of the other. If this is a pure function, it's very independent from the other. If you can call each of those functions without needing to call a class. But in this case, now you first of all need to instantiate the login class with the new keyword, create a variable of type login before you can then be able to access it like a login dot validate image. So what we will need to do then is to say const login like this equals new login. And then we need to pass something here now for the email. And then we pass another thing here now for the password. And Jesus Christ, stop now. My baby is falling. The source is slippery. Check. Now, so before we can access all those methods, now we then need first of all to call the login method variable we've created here, and then we can see those methods here. Now we can then call validate email, and it will validate the email. We can then call validate password if it validate, and then call the submit before we can submit. But if it is functional, we can just be calling the functions anywhere we need them, and they will go. So this approach is also very good, but sometimes you might need to do more functional programming, and in other cases you might want to organize your code in a bit in a class-based approach, and that is also fine. So most of the code will be writing at first as we begin our work will mostly be function, and then we can, before we start also making use of classes in different places. Okay, I think that is all we do about our class today. Let's look at what again do we have. Let me remember when you call a method like this, it's usually referred to overriding, because this method exists in the parent class, but when you call it, you define it again in the subclass, you are overriding what is the method definition on the parent. So even if you are calling again a property like name here, which is existing in the other parent, you are also overriding. JavaScript doesn't require you to do override like in some languages. You need to call override like this, sometimes at override, and then before you'll be able to override an existing class. But in JavaScript, you don't need all those things. Just call the name of that method you want to override, and you'll be able to do that. Now, apart from inheritance and overriding, there are also the inheritance is achieved by extends. Use it to inherit from another class. Then overriding is achieved by just redefining your method in your subclass. You already achieve overriding. Then there is also another type of class usually called abstract, and some of these object-oriented languages have abstract. Yeah, they usually have abstract like this. But when it comes to JavaScript, you can't actually define an abstract. It doesn't support that. You can only use it in TypeScript. When you compile that to JavaScript then with the compilation, we do the conversion to normal class in TypeScript. But in other OOP languages, you can see something like abstract, but it's not necessary in JavaScript. We also have other OOP features like polymorphism. we have polymorphism, and the polymorphism is also one of those important features. We also have another one called encapsulation in object-oriented programming. Now, in polymorphism is a situation where object-oriented programming helps you to make something to appear in different form. That is, poly is many, and then for the phism there is referring to form. So it gives you that possibility of creating your properties or making your something to appear in different form. So that is like we see, you can create an object of different form with that polymorphism. You'll be able to create object of different form in JavaScript. But for the abstract, what is helping you to do is hiding properties or implementation. It's just like display. You can access display until you are able to instantiate the electronics. So this electronics is encapsulating this particular property. It's wrapping it inside itself. So before you can be able to access something that is inside, you have to first of all get access to it, or it has to be exposed by the person who created. But if it is not exposed, you won't be able to access it. So that is one of the things that it helps you to do. So if you using object-oriented programming, there are these features that it gives you that helps you to properly secure your code. Unlike the functional programming, you can just be calling the validate email, validate password, but in this case, you can't access those functions, those methods until you have been given access. You have been able to instantiate the login constructor or function class which we created here. Only then and then that will you be able to access the particular property of that particular class. Yeah. Okay, we keep on looking at these other features I said we will look at. What we look at tomorrow will be validation. I said that this is more important for us to get before we look at these other features, other things uh, in our plan. So if you have good understanding of this object-oriented programming, this is the basic of all you do in object-oriented programming. And for there is also something called implementation apart from this, because JavaScript has in support that is available in TypeScript to implement, not extend, but that is not default in JavaScript. So in that case, it's actually working with interface. Interface is not available also in JavaScript. So when we treat TypeScript, we'll be able to dig deeper into those ones. Now you see that one thing about the extend, the parent class product does not have the properties of the subclass like electronic. It's only the electronic that is extending the product that will have the properties and the method of product. So it's something that only goes in one way. You're the one that extend this order is the one that inherits the properties of the order. So when you do the extend, you are inheriting everything that is in the one you are extending, but the one you are in extending does not inherit anything from you. It's just like a child and a parent. When this child, the parent grows old and he can leave inheritance for his child. But in a normal circumstance, it is not that nowhere where someone people be expecting the child to leave inheritance for the parent. is something that is mostly in one way direction. You leave the child inherits from the parent and not the other way around. So in programming, also in JavaScript in particular, the inheritance is also from parent to child. Child inherits from parent. And there is also some platform that supports multiple inheritance, but in this case, let's define a class to see, let's say a class as a person, then we just leave it here, and we come here and put comma person. Now you look at what we are seeing here is underlining the person. This thing is invalid in JavaScript. What this means is multiple inheritance. That is a single class like electronic inheriting from more than one class. JavaScript does not allow that. You can inherit only from one class, but person can extend electronic. A person can extend electronic. So instead of calling this person, let's just say laptop. So laptop can extend electronics. So, but electronic cannot extend anything to. So instead of doing multiple inheritance, what you can do is to come create another class like this and extend the other. So let's say now we want to add new properties. We now say like RAM size, say CPU clock. And these are properties that are peculiar with laptops. So we can then say this dot RAM size is equals RAM size. This dot CPU clock is equal CPU clock. Now, if we create a laptop, let's create a laptop like this. So we call this laptop. It's a new laptop. Now we have, what do we have here? RAM size. Okay, so let's remove this and say RAM size is, let's say 16 gig RAM. We're expecting a number, so we just say 16. It's always in gig. And let's say, what again, CPU clock, let's say 4.5. We can make it in gigahertz, so we can make it string. Okay, so this also we can make it string and say is 16 gigabytes. Here you see that we can also, if we come here, let's say we can say this dot name. What are the things in a property? In okay, we have a brand. Say this dot brand. First of all, we call super. Then we can say Apple. Okay. So if we look at where do we have? Oh yeah, electronic. We define electronic after this. So let's come under. What am I saying? Class laptop extend electronic. I'm extending the little one which you created, which is wrong. But again, product 2 before initialization. Oh, I'm not calling, so I call laptop here. Okay, so if we come here and look at our laptop, you see that we have all the properties that are in the parent. Now look at, let's be careful now, you look at in our laptop, what we have new is the brand. We have the brand. Do we have brand as new? We have CPU clock, RAM size 16 gig RAM. CPU clock, we have 4 gig RAM, 4.5 gigahertz. Now we also have the brand. The brand we put Apple. Now look at, if you come to where we did the definition, here we say this dot brand, we already assigned Apple to it. Now, all the other ones, we didn't assign anything. Look at color is undefined, price is undefined, and then name is also undefined. And where do we define name? You know, see that name is something that is in product. Name is not even defined in electronics. It's not a property of electronic directly, but that of product. So now we are extending electronic, which extend product. And you are seeing that or even the property that is down to product is now given also to laptop. So this is telling you that when you extend a class that extend another class, both the properties of the class you extend and the one that that particular one also extend is going to be inherited by the new class. So we can add all these other properties when we are defining laptop. If we add them in the constructor, we want to accept all those things, they will be given values. We can say name, we want to accept name, then we can also say what again, price, and then color. We can put all this now, then we can come here, then let's say this dot name, and then we say MacBook, MacBook, let's say MacBook 16. We say this dot price, say $2,000, and what again, this dot color, then we are seeing the color is gray. Yes, we are giving it the value. We just want to be fast so that we don't need to add value to them in our constructor here. So when we open here now, you see them. Even if we don't have them here, we remove all the values here, and then we say this the brand name, brand equals brand, name is equals name, and price is equals price. Color is equals color. If we do this here now, we can still come here. Let's put a brand here. We can come here and I put our brand and say is Apple, and then the name is MacBook 16, and then the price is 2,000. The color is gray, and then we see in our laptop, where is our laptop, you see all those values we added, we can see them here. So even at this point, when we still come down to our laptop, be able to see all those properties, they are still now available. So that is it about the inheritance. You can inherit down to a higher level, like third level in the inheritance chain. You inherit from the one that inherits from another. All those inherited properties will still be given to you. If we still open this now, any of the method that is okay, if you define any method here, it will still be available. And what we are seeing here, class laptop, and then you see it also is pointing to the electronics which it inherited, but it will point to the product which inherited is stopping at this level of electronic. So this is it about the inheritance. It can move up to a higher level. Okay, so you have any question? Or we close at this moment and then we continue again tomorrow. Chinedu, concerning your GitHub, please try get it sorted out. Or if you need help, you can book a session so that I can give you assistance. We'll sort that out quickly. Okay, guys, we call it a day. Do enjoy the rest of the night. We meet again tomorrow.
Thank you, sir.